So hello friend, once again to DD Tutorials. We dream, we design and we deliver. Myself DD sir. Today we are going to start our new topic, which is bond cleavage. So types of bond cleavage is our first topic. Bond cleavage. Organic reaction is a process in which breaking and formation of covalent bonds take place. As we know, we have studied in our earlier classes what are covalent bonds. Covalent bonds are the type of bond which are been made through the sharing of electrons. In organic reaction, the organic compound which is converted into a new compound by breaking and formation of compound as the reactant or subtract, and the new compound form is known as product. Here we can use subtract or reagent, both are the same term. We do the reaction and as a result we get a product as our answer. Breaking of covalent bond is known as bond cleavage, because cleavage itself intensify that there is a breakage of bond. The bond can be broken into two ways. One is homolactic and second is heterolactic. In homolactic we get free radicals, and in heterolactic we get carbocations and carboanions. This will be studying in the upcoming slides. Okay. Now we are going to study types of fission. There are basically two types of fission. One is homolactic fission or homolysis, and the second is heterolactic fission or heterolysis. Homolactic fission, in which we get only free radicals. What are free radicals? The homolactic fission gives free radical as the reaction intermediate. Here we can see that A and B are bonded by one bond. It's not visible clearly, but they are bonded over here. After their cleavage, one electron will be taken by A and one electron will be taken by B. As a result, A has one electron over it and B has one. As a result, they both are free radical. The factor which favors homolysis is 0 or small difference in electronegativity. Homolactic fission takes place in gaseous phase in the presence of nonpolar covalents. We need to remember that CCl4 and CS2 are going to be used in our upcoming chapters. They are very important non-polar solvents. Now we are going to study about heterolytic bond fission. In heterolysis, the covalent bond is broken in such a way that electron pairs are taken by one and the other atom is left empty. Here we can see that A takes both the electron and B get positive charge over it. So the compound with negative charge is known as carboanion, and the compound with positive charge is known as carbocation. The factor which favors heterolysis is greater difference of electronegativity between A and B. This happens because of electronegativity difference between A and B. Now we are going to study about carbocation. An organic species which has carbon atom bearing 6 electron in its outermost shell and has a positive charge is known as carbocation. It have a positive charge over it. Carbocation have positive charge. Positively charged carbocation has only 6 electron in the outermost shell. Since all the electrons are paired state of carbocation, they are diamagnetic. Diamagnetic is a term which we have studied in our chemical bonding class. Now the carbocations are sp2 hybridized. The carbocations are formed in polar protic solvent. This we need to underline this topic because it will be used in our further chapter. The most important topic of this is the last point given over here. It's stabilized by the presence of electron donating group. This we will study when we deal with the acid and basic strength. Now we are going to study carbocation. Anion of carbon is known as carboanion. Carboanion carries 3 bonds and 1 lone pair because it has took the electron pairs from the other atom. It is formed by heterolytic bond fission. It is very clear. It has 8 electrons because 2 electrons are borrowed from it. It behaves as a nucleophile. We will be studying nucleophile and electrophile also later on. It is diamagnetic character because all 8 electrons are paired. It has basically sp3 hybridization and pyramidal geometry. This all we have studied in chemical bonding. It reacts with electrophiles. It stabilizes the presence of electron withdrawing group. It reacts with electrophiles because electrophiles are electron deficient and carboanions are electron excess. Hence it can donate its electron to them. Now we are going to study about free radical. It is one of the most, not very important, but a small topic which we need to take under consideration. Carbon free radicals are odd electron species in which